Hello students, hope all of you are fine. Today I will be discussing matrix inversion method. So then a matrix will be given to you. You need to find the inverse of the matrix. Generally in high school mathematics, we generally uh, calculate the inverse of the matrix by finding the adjoint of the this matrix and divide by the determinant of that matrix, right? Adjoint of suppose A by determinant of A. If A is my matrix, okay, this gives my inverse of the matrix. But instead of doing that, we can utilize this Gauss elimination method and Gauss-Jordan method, which I have discussed in the last two classes videos. You can check. We can utilize that concept to find the inverse of a matrix. So without wasting any time, let's see what is this method all about. Suppose this is your A. It will be given in the question. You need to find the inverse of the matrix simply. And today in this class, we will be using this Gauss elimination method. So if you can recall, Gauss elimination method means we need to change that A part to an upper triangular form. That means the elements below the diagonal elements should be 0. Okay. So what you will do here is, first step is you need to concatenate an identity matrix with the matrix given. That means if I say here is A, so concatenate A and I means any identity matrix, and the size of the matrix will be 3 cross 3. Why 3 cross 3? Because this matrix is 3 cross 3. If it is 4 cross 4, then you need to have in 4 cross 4. Fine. So this is what you need to do in the first step. Now what you need to do is you need to change this part to an upper triangular form. We have did it in the we have done in the Gauss elimination method, right? So you need to change that part to an upper triangular form. So first step of operation is you need to change this two element to 0. This is what we have done in that class. So here also you will be doing that. We will be changing these two elements to 0. Okay. So to make this two elements 0, I am performing two row operations. First one is I am changing the second row by R2 minus R1. R2 minus R1. So see if you can subtract. So 2 minus 2 is how much? 0. So diagonally you got 0. And if you subtract the whole row, you will get this. Simply this row. So how much? 3 minus of 2, right? So 5. 2 minus 4 is minus 2. 0 minus 1 is minus 1. 1 minus 0 is 0. 0 minus 0 is 0. So this is what I have done. Now at the same time I am doing this operation R3. We are changing the row 3 by R3 plus half into R1. Why? Because I want to make this element also 0. Okay, so to make this element 0, I am performing that operation. So see, check. R1 is R3 is how much? In this case is minus 1. Plus half into R1 means this 2. Half of 2 means 1. So minus 2 plus 1. Sorry, minus 1 plus 1. How much? Is 0. It's 0. Okay. Similarly, see, I have written here minus 1 plus half into 2 is minus 1 plus 1 will give 0. Now this you will get if 4 plus half into minus 2, that means 4 plus half into minus 2, that will give 3 minus 1, that will give 2. 4 minus 1, it will be 3. Okay, so change this is 4 and this should be 3. Okay, so you will get 3. Similarly, you will get the rest of the terms. So these two operations you need to do for this problem. Now my next step is, this is my part A. Next part is to change this element 0 to make this element 0. What I am doing here is I need to obviously change the third row because this element is in the third row, and I am performing this R3 minus 3 by 5 R2. 3 by 5 means this one. So this one is 3, and if I need to make this 0 by involving this one, so I need to multiply this one by 3 by 5. 3 by 5 into R2 minus this whole row will give this 0 out here. Okay, so 3 minus 3 by 5 into 5, 5 cancels out, 3 minus 3 is how much? 0. Okay, and other terms will get this. So 11 by 5, see here. Here is 1 minus 3 by 5 into minus 2. So 1 minus 3 by 5 of this row. So 1 minus 3 by 5 of minus 2. Okay, so this is 1 plus 6 by 5. This will yield 11 by 5. And for this case, half minus 3 by 5 minus 1. So half plus 3 by 5, this will yield 11 by 10. Okay. So half minus 3 by 5 of minus 1. So half minus 3 by 5 of minus 1, if you solve it, you will get 11 by 10. And you can calculate the rest of the terms. Okay, you can do that. Simply you take this operation and perform. You will take out a pen and paper and you will do this. You can do this, I hope. So this is now this matrix becomes an upper triangular form. So this is the base of this Gauss elimination method. Now the twist, now the change is here. What you need to find the inverse? We need to write the equivalent systems of equations. Equivalent systems of equations simply very easy. It's Ax equal to B. We know that. You need to write this as in X plus X equal to B form. So see, this is your A. So this is your A. What is your X? X is the, suppose the unknowns, X, Y, Z. You can choose X1, X2 and X3. You can choose anything because it is not given in the question. So you can choose any variables. And what you need to do is, what is your B in this case? B is the first column of this, of what remains after this dotted line. That means the first column, this one, this column will be your B for this equation. Fine. Now, simply what you can do is the last part of Gauss elimination method, which is back substitution. Suppose perform this multiply operations, you will get this and this. So if you solve this, Z is equal to half, and then if you put Z here, that means back substituting, you will get Y, and if you put Z and Y both in the first equation, you will get X. So this is a process of back substitution. So you will get three values, right? Minus 1, 0 and half. So remember one thing, this what you got for this case will be your first column of the A inverse matrix. So this is your A inverse matrix. What you got? X is minus half, Y is 0, Z is half. So this is what you got. Simply write these three values. Okay. Now what you need to do is, again go back. This is your A. Again your X part. So Ax. Now this B will be your second column of this part of the matrix. That is what remains after the dotted line. So this will be 0, 1 minus 3 by 5. 0, 1 minus 3 by 5. Again if you multiply and if you find x, y, z, values of x, y, z, you will get this. 7 by 11, 1 by 11, 3 by minus 3 by 11. So these three values of x, y, z will form the second column of the A matrix. Okay, second column of the A inverse matrix. Sorry, 7 by 11, 1 by 11, minus 3 by 11. It is the second column of your A inverse matrix. Similarly, the last one remains simply same A, same X, But this B is now the last B. That means the third column, last column, 0, 0, 1. So 0, 0, 1, if you solve it, you will get again the values of x, y, z, and simply write down in this order, x, y, and z. So now this part is over. Now you will get the A inverse matrix. So this is the process of finding the inverse of a matrix by Gauss elimination method. So basically we are again utilizing the triangular form. Again we are separating this systems equations, and we are finding each column at a time. Okay, and how do you get the values of the each column? Simply xyz by back substitutions. Okay, so this is basically the process is very easy. You need to just practice. If you have any doubt, you can call me or contact me in my WhatsApp number. Stay safe. Thank you.